Welcome to the deep dive. Today we're going to try and cut through, a lot of the specs and really get to the core of an engineering challenge.
A big one.
Yeah, a big one. How do you get huge data streams from a fiber backbone right into someone's home? And we're looking at one specific piece of hardware that does it. The Thor Broadcast F-MININODE-2RT.
I think bridge is the perfect word for it. It's the essential bridge component.
The bridge between what and what?
Between the world of pure light signals on fiber and the radio frequency signals inside your house. You see this in fiber to the home and also in those older hybrid fiber coax systems.
Okay, so it receives the signal, but what really stood out to me is that it's bidirectional. It's an optical receiver and a return path transmitter.
That's the whole ball game right there.
So let's unpack that. If it's built to receive this perfect, clean signal from the fiber, why is sending data back that return path so incredibly complicated?
That really is the billion-dollar question, isn't it? The problem. Yeah. Well, it all comes down to the frequency band that your cable modem uses to talk back to the network.
Okay.
It uses this really low frequency band, specifically 5 to 45 megahertz.
That's low.
It's very low. And you can think of it like a tiny, crowded side road that has to carry all the upstream traffic for an entire neighborhood.
Right, and I know those low frequencies they're magnets for interference, what the engineers call noise ingress.
Exactly. They pick up everything. Electrical noise from your fridge, a neighbor's ham radio, you name it. It's a mess.
So this unit's innovation is how it solves that specific headache.
It is. So while the main TV signal comes through clean on the 45 to 870 megahertz outputs, that really critical upstream signal gets special treatment.
So.
It's managed by an optional optical transmitter. It takes that weak, noisy 545 megahertz modem data and converts it back into a laser signal on the fiber.
So it protects it. It gives it a clean, interference-free ride back to the head end.
Precisely. It turns a noisy side road into a private expressway.
That puts it in a different category. It's not just a piece of gear. It's an elegant engineering solution. And something else in the specs just jumped out at me. The range?
Yes. The distance it's frankly astonishing.
25 kilometers.
25 kilometers. And we're talking about high-definition data delivery over single-mode fiber. That kind of distance, it just fundamentally changes the economics of how you build a regional network.
You can service a huge area from one central point.
A massive area. And you're not sacrificing quality. This thing supports full 1080p, HDTV, and high-res computer displays, too.
Maintaining that clarity after converting light to RF across 25 kilometers, that says a lot about the precision of the components.
It does, and that precision is built for serious reliability. This isn't consumer-grade stuff.
I saw it mention plug-and-play interfaces, which sounds simple.
It is simple to install, but the key detail is that it's TAA compliant.
Meaning it meets federal government procurement standards.
Right, which is a huge marker of quality and ruggedness. It means it's built for major carriers, for government installations, for places where failure is not an option.
So when we put this all together, what does it really mean for you, the person at home? This little box, this F-MININODE-2RT, is sort of the unsung hero managing the hardest part of your internet connection.
It's managing that two-way communication over these incredible distances. It makes sure the part of your connection that handles uploads, gaming, video calls.
The interactive stuff.
It ensures that path stays clean and stable, even if you're 25 kilometers from the source.
That's what separates modern infrastructure from the old stuff.
Yeah.
That ability to manage the noise-sensitive return path optically.
Absolutely. And it leads to a pretty interesting question, considering our demand for bandwidth is just, it's always going up.
Yeah.
Well, if this technology can already push that clean signal out to 25 kilometers, how quickly do you think we'll see that limit pushed even further? That's something for you to consider.